This is Mr. Anderson from Kellogg Community College. We're going to be looking at Section 7 of Chapter 6, Synthetic Division. In this short video, we'll show you a pretty cool shortcut that's useful for some problems that really you'll want to use this versus long division. And when I say some problems, if you kind of take a quick scan through this page, you'll notice that each of these problems here have some form of division problem where it's just a single x minus or plus a number. This right here is to test whether or not this is a factor of this. And in our previous section, we did long division, where if we had a remainder of 0, then that would be the that would tell us if it's a factor. Within synthetic division, it's only useful when we have x plus or minus some constant value, and if you have a number in front of x, it won't work without some modification. Now, there's a couple things that we need to know about synthetic division. First of all, everything has to be in the format of x minus this constant term. So what we're really checking to see is if the graph is crossing at 3, not -3, +3. So the number we start off with is the opposite value of the value that's being brought away from x. So if we have -3, then we're really testing 3. And this is proven because if we have x minus 3 is equal to 0 and solve for x, then x is equal to 3. So the big question is, in this graph right here, is the line crossing at the 3? Yes or no? And the answer to that is if we get 0 as our remainder, then yes, it is crossing at 3. And if we don't get 0 as a remainder, then it is not crossing at 3. So what you could do is look at your graphing calculator. You can type this equation in and go to your table to see if it does cross at 3. But without that, you can use our leading coefficients and our other coefficients to set up this little bit of a simple single matrix here. This is going to be a single row using the coefficients of x cubed, x squared, x to the x, and then no x, or x to the 0 power. So what we're going to do is, in synthetic division, we're going to drop the first number here and then go 3 times in this diagonal, 3 times 1, which makes us 3. Add these up, -4 and 3 makes a total of -1, and then multiply this by 3 again. Now anytime we go across here from there, we're going to multiply. 3 times -1 is -3. Drop that. Put these together, that makes 2, and then we're going to multiply the 3 and the 2 right there, and that's going to make a +6. And if we add that together, you'll notice then we have an answer of 0 in this final spot, which means that yes, this does cross at 3. And what's kind of nice about that is what's left here, as this was the x cubed, x squared, and x spot, this now becomes x squared minus x plus 2. This is our remaining answer after we factor out this x minus 3. And there's our answer there. There is no remainder. And so this is a much shorter technique than using long division. And it gets us to the same answer that we would have in the top of our long division problem if we had our x minus 3 out in front and our x cubed minus 4x squared plus 5x minus 6. So here's our answer, no remainder, and it's a really quick way to do this. Looking at problem 2, we're going to use instead of a 2 there, sorry that I kind of made a little mistake there, we're going to look at the x plus 5, so we're going to put -5 to test to see if this crosses that x-axis at 5, or -5 in this case. So we're going to go 1, 8, 11. All right, drop the 1, multiply 1 times -5, put these together to make 3. -5 times 3 is -15. Oh no, there's a remainder. And the remainder here is -4. So it looks like my answer is going to be from this 1 and 3 right here. This is going to be x plus 3. And then what we're going to have is a remainder plus -4 over x plus 5. And again, this is, an alternative to doing the long division problem, x squared plus 8x plus 11, and we have on this side x plus 5, you would see that we would start out with x plus 3, and you can do the long division out if you want to, and then you'd have a remainder of negative 4 over x plus 5. So synthetic division gets to the same answer as our problem here. It's just that it doesn't do the long processes we saw on the previous worksheet, or the previous worksheet and the video. Now some of you are wondering, like, well, how did 1 and 3 turn into x plus 3? Well, if we factored out an x plus 5 from this, the power gets lowered. So this becomes 1x instead of the normal x squared. And then this has one fewer power of x, so that's how that has no x by it. So there's our final answer to problem 2. And you'll see as we keep doing these problems here, you'll see that these 3 problems are actually going to go pretty quickly using synthetic division. Okay, so what I'm going to do first here is I'm going to take a look at this x minus 4. So the number I pull out is going to be a positive 4, checking to see if this intersects at x equals 4, and at the same time wondering if x minus 4 is a factor of this. So using my coefficients, I've made my little row, and I'm going to drop the 3. 4 times 3 is 12. 12 and 10 make positive 2. 4 times 2 is 8. Negative 9 and 8 make negative 1. 4 times negative 1 is negative 4. 15 minus 4, oh no, it's a remainder of 9. So this is 3, 2, 1, and 3, 2, 1, since we pulled out of x minus 4, the power is going to decrease by 1. So my answer is 3x squared plus 2x minus 1 plus a remainder of 9 over x minus 4. In problem 4, let's go give this a try. The number we're going to pull out here, this is x minus 3, is going to be a positive 3. Notice this is x cubed, so that's 1. We have no x squared here, so we need a placeholder, just like we did in the long division problems. When we had a missing x, we would put a placeholder in there. So now we're going to do our long division. Drop the 1. 1 times 3 is 3. 0 plus 3 is 3. 3 times 3 is 9. Negative 14 and 9 make negative 5. Oh, check this out. 3 times negative 5 is negative 15. We have no remainder. And since we have no remainder, our problem is factored into x squared plus 3x minus 5 with no remainder. This means it factors it completely. If you ever want to check your answer, you can just multiply that by my x minus 3, do your long multiplication, your distribution, and you can see that this gets us back to our original x cubed minus 14x plus 5. But our answer would just not have that on it. This would be our answer with no remainder. Number 5, we're going to have a negative 2 out in front. We're going to have 2, negative 3, 0, and 8. Now why is 0? Well, we have no x right there, so that's something to look out for. Draw my line, and here we go. Drop the 2. 2 times 2 is negative 4. Drop that, making a negative 7. Negative 7 times 2 is positive 14. 14 and 0 is just 14, and unfortunately, when I multiply 14 times negative 2, I get negative 16, which gives me a remainder of negative 8. And, oh shoot, I made a mistake there. Negative 2 times 14 is negative 28. Sorry about that. And then putting that together gives me an answer of negative 20. Whoops, sorry about that. Just don't feel in the mood to go and redo all that work for that little flub there that I caught pretty quickly. So our remainder is negative 20, which means that we have our answer of 2x squared minus 7x plus 14 with a remainder of negative 20 over, let's see here, x plus 2. Okay, so for our final 2 problems, synthetic division actually has another use besides long division. It's useful for substitution. Now granted, what we would normally do here is plug the 3 into each of these locations to evaluate what my answer is for g of x. just plugging 3 times 3 to the fourth and negative 25 times 3 squared. But we can also use this here. Now, in this case, you would not actually change your value at all. You would just use the 3 because that's really what we're evaluating. So this would be 3x to the fourth, 0 minus 25x squared, 0 minus 18. And so instead of substituting the 3 into the equation, we can just use synthetic division. Drop the 3 from here. 3 times 3 is 9. Add these up, which makes 9. 3 times 9 is 27, which makes negative 2. 3 times negative 2 is negative 6. Add this to up, negative 6. 3 times negative 6 is positive 18. Our answer is 0. So g of 3 is 0. So if I plug 3 into this equation, and we can check this by going 3 to the fourth power times 3 minus 25 times 3 to the second power minus 18, that would give us 0. Same thing goes over here. This problem has x to the fourth, 7x cubed, 11x squared, negative 7x, minus 12. So again, this is going to evaluate what the answer is going to be if I plug 2 in for this, 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 and this. So we're not actually looking for factoring, we're looking to see what that would be when I substituted that in. So drop the 1, 1 times 2 is 2. 7 and 2 make 9, 2 times 9 is 18. 11 and 18 is 29, 29 times 2 is 58. 58 minus 7 is 51. 51 times 2 is 102, and my answer here is going to be a positive 90. So if I plug for my h, if I plug 2 in for every value of x, I would get an answer of 90. All right, thanks for watching.